Okay, think about the moon. You've probably looked up at it a million times, right? It just hangs up there, silent, still, totally separate from us. But what if I told you that for billions of years, our planet has been secretly interacting with it, leaving behind a telltale sign we're only just now discovering? It's like this bizarre cosmic crime scene, and we're about to dive in.
So right off the bat, here's the central mystery. To get rust, you know how this works. You need three basic things: iron, water, and oxygen. Now the moon has tons of iron, sure, thanks to all the asteroid impacts. But it's a vacuum. It has no air and no liquid water. So how in the universe is it rusting? It's a paradox that completely baffled scientists. Well, the mystery has been cracked. And it turns out the prime suspect isn't some weird alien phenomenon or a bizarre chemical reaction we've never seen before. Nope, the culprit is shockingly close to home. In fact, it's us. It's planet Earth.
Okay, so to really get how this happened, we've got to go back to the scene of the crime and look at the single piece of evidence that blew this whole case wide open.
A little while back, India's Chandrayaan-1 orbiter was scanning the lunar surface, and it found something that honestly had no business being there: hematite. Now that's just a fancy scientific name for common iron oxide. In other words, plain old rust.
And that's why this was so mind-blowing. Let's just break it down. The recipe for rust on Earth: iron, check. Water, check. Oxygen, check. But on the moon, you've got the iron, but no liquid water and no atmosphere to provide the oxygen. The recipe is missing two of its most critical ingredients. So where did the oxygen come from?
The answer brings us to a pretty shocking conclusion. The missing oxygen wasn't from the moon at all. It was an import, delivered directly from our own planet.
Yeah, you heard that right. NASA actually describes this process as a larceny in space. For billions of years, the moon has been secretly siphoning off tiny bits of our atmosphere. It's this cosmic heist that's been happening right over our heads the whole time.
So, how is that even possible? Well, it kind of changes our whole idea of where Earth ends and space begins. We usually think of our atmosphere having this hard cutoff, but that's not how it works. It doesn't just stop, it just gets thinner and thinner, leaking out into space.
And I mean, it goes way out there. Our planet is wrapped in this massive, invisible cloud of gas called the geocorona, and it extends a staggering 400,000 miles out. That's way past the moon's orbit. Our neighbor is basically marinating in the outermost wisps of our air.
But just being bathed in our atmosphere is only part of the story. For the oxygen to actually cause rust, you need a dedicated delivery system, a way to get it from Earth's edge and plant it squarely onto the lunar surface.
And that delivery system? It's Earth's own magnetic field. See, the sun is constantly blasting out this stream of particles called the solar wind. When it hits our planet, it stretches our magnetic field out behind us like a long scarf caught in a breeze. Scientists call this the magnetotail, and it acts as the perfect delivery truck for our atmosphere.
So here's how it all comes together. First, particles from the sun smack into our upper atmosphere and knock oxygen atoms loose. Then, our magnetic field grabs these charged oxygen ions and funnels them down that long magnetotail. And here's the kicker. Once a month, the moon passes directly through this oxygen-rich tail for a few days, getting sprayed by what scientists call the Earth wind, a stream of our own planet's oxygen.
And this isn't just a theory. We know this for a fact. Japan's Kaguya probe was in the perfect position to witness it. It measured a clear spike in oxygen from Earth every single time it passed through our planet's magnetic wake. Case closed.
But this is where the story takes a fascinating turn. What begins as a tale of cosmic larceny actually reveals something incredibly beneficial for humanity's future. So, is the moon a thief? Well, the amount of air it steals is so tiny we'd never ever run out. But what it gives us in return could be priceless. This isn't theft. It's the creation of a cosmic backup, a massive win for the future.
Think about it. This oxygen is now locked away in the lunar dust. For future astronauts building a base on the moon, this is a total game changer. That oxygen could potentially be extracted and processed into breathable air or even combined with hydrogen to create water. The moon has been storing a vital resource for us without us even knowing it.
But the implications go even deeper than breathable air. This discovery reframes the moon entirely. It transforms it from a desolate rock into an incredible historical archive of our home planet.
Here on Earth, our geology is always in motion. Tectonic plates shift, weather erodes rock, and old surfaces get recycled,
constantly erasing the evidence of our planet's ancient atmosphere. But the moon, it's geologically quiet, cold, and static. It doesn't erase its past, it preserves it. This means that somewhere, locked in layers of lunar soil, there could be oxygen from Earth dating back 2.5 billion years, right around the time when early life first started pumping our atmosphere full of it. The moon could hold a pristine record of the evolution of our own air. And that really is the most profound takeaway here. The next time you look up at the moon, remember it's not just a rock, it's a time capsule. For billions of years, it's been patiently collecting and preserving a fundamental piece of our home.
Which brings us to our final question. After all this, how do you see the moon? Is it a sneaky neighbor engaged in a bit of cosmic larceny? Or is it humanity's most important and most ancient backup drive? It seems what began as a cosmic crime is actually Earth's greatest accidental gift to our future.